Have you ever become frustrated by a computer error message or program warning that didn't provide the engineering reason or any clue about what the problem might be? Software developers can be guilty of providing warnings and error messages that state what has happened, but do not tell the user why or how to rectify the problem. Developers can also use the same error message for a number of different problems, making it almost impossible for the user to know how to fix the problem in the model without using a program debugger.
My name's Phil Senior, and I am the Principal Engineer for the Autopipe brand at Bentley Systems. In this seminar, I will show you how you can obtain more information about the error messages in order for you to determine the corrective action.
So let us take a look at this error message as a typical example of what you can get. This is an actual Autopipe error message that I got when reviewing one of our users' models. From reading it, I had no idea what it meant or how to fix the model. Fortunately, these Fortran runtime errors are quite rare. But this is a typical example of an error that says what is wrong, but doesn't provide any clue as to how I might fix the problem. So if I can show you how you can find out what these error messages actually mean and how you can fix your model without requesting technical support, would this be useful to you? I hope so. So in today's Tech Talk, we will start by looking at the category of different errors. I will then show you what information is available in the Readme file and how useful it can be, something many users simply ignore. We will then consider two examples and demonstrate how to use the information available to understand what is happening. One will have errors and warnings in it. The other will show different results from identical models run at different code years. After that, we should have time left for Q&A, so please consider some questions and type them in the chat window. So let's go back to our Fortran runtime error. At first glance, this doesn't mean much to a mechanical engineer who is not a programmer. However, even I can tell that this error is something to do with an incorrect position and relates to the .mod file, which indicates it is something to do with the modal results. But how does this help me? It doesn't really. So would you be surprised to learn that there is a detailed description of this known error and information as to its cause and possible solution documented in our wiki? You can see here, in fact, it is something to do with the modal analysis setup. Categorization of errors. The errors that are the most severe are the ones classified as critical. They might be very minor in effect and difficult to invoke, but the fact that the result could be unconservative is sufficient to categorize them as critical. Any critical errors in our QA&R released version are formally notified to our nuclear users in line with the 10 CFR 21 requirements for those who subscribe to the QA&R program, due to the unconservative nature of them. A full detailed report is available to QA&R subscribers to ensure that they are aware of the impact on their design and how to mitigate any problems. These errors are assessed and repaired without delay. In addition to the formal notification received by our QA&R subscribers, all users will be made aware of the critical errors that might affect their models when they are opened in later versions. The program assesses the model and what load-ins are present and shows only those errors that are related to it. The idea is not to overwhelm the user, but to prompt them of the changes that have been made to the program since the version they last ran the model in, and how that might require them to investigate this further. A brief description of the error can be obtained from the evaluation report indicating the node location that the error applies to. The next level down are high errors. These are like critical, but are conservative in nature. They still receive urgent attention as no avoidance exists. Medium errors have effective avoidance processes for primary functions and include secondary functions without avoidance. And finally, low errors include everything else. A list of the critical and major errors are reported in the Autopipe wiki and are recorded against the version that they were found in and repaired in. A list of all errors is also available in the Readme file. Not only is there a list of errors in the Readme file, it is also full of other information to help the user understand how the product has changed between versions. It provides lists of changes made to the program at each release, used to determine when the change was made and if it affects you. Autopipe functionality that is covered by the QA program. The status of the piping codes in each release. And the fixed error history that also aligns with more information on the wiki, as well as other hyperlinks to our online material. Okay, so the Readme has some good stuff in it, but where is it and how can I find it? If you are running version 9 or older, you will find it in the program startup directory, as shown. In version 10, we have also added a link to the program help called What's New and Changed. In the new version 11, it also has a direct link from the help ribbon. And in all versions, it can be opened from the Help About dialog. In addition, the Autopipe wiki also has the release notes for all versions. Warnings and errors. So let us see how the information can help us with problems in our models and resolve them without having to wait for technical support. In this first example, there are a number of error and warning messages that appear while we're working. I've opened this model in an old 9.6019 version. Running the analysis gives a couple of error messages E801-1. At this stage, they don't mean much to me. I can use Google to search for Autopipe error code E801-1. You can see that the Bentley community site is the location of the first search result for error code 801-1. It illustrates some of the reasons why this error code occurs, and in this case there are 6 different scenarios. For us, the scenario 1 is our problem, an unsupported segment. So which segment is it? We can use some of the view tools to investigate. The Show Connected Segments shows the unsupported one. There is no support on segment CH and is not connected to the rest of the model. Modify the T-point C00 and connect it to CG01 will fix this problem. Rerun the analysis and we no longer have the E801-1 fatal errors. We do have a liftoff warning, but we will ignore this for now. I will undo that modification. You can see that the node number has changed back. Analyze again, and this time read the consistency port. A clue was in the report all the time. Redo the change and save the model. Warning and errors continued. So let us open the very same model in a newer version. This one is the latest Readme version, version 11. This time we get a warning W511-67. I need more information about this. Use Google to search for W511-67 and show it in the wiki. It talks about a new nonlinear hydro test method that wasn't available in version 9.6 earlier. Checking the Readme file for version 9.6111, you can see that this feature was added after 9.60. So let's run the analysis. Ignoring the liftoff warnings, we also get an error message E801-3. Using the B community search directly to find information about E801-3, it tells us we have an empty analysis set. Opening the static analysis set, we can see that there is indeed an empty analysis set. Delete the empty load set and change the new hydro test analysis to a nonlinear. Rerun the analysis. The error has gone. However, we now have a warning W507-40, no thermal case included for nonlinear hydro. Using the B community search again to find information about W507-40, it tells us that there is no thermal case specified. This may have been intentional, hence only a warning. Checking back in the analysis set for the hydro test settings, we can see that there is no thermal case specified. However, this was my intention, so we can leave it as is and ignore the warning. Using the consistency report, we can check for obvious problems and resolve them. Checking warnings, we see material properties warning, a two-legged T at node D01, and some changes in OD which are probably okay. The two-legged T is a concern, so let us use the tools we have to find the node D01. The T looks fine. It looks like it has 3 legs, but it only has 2 due to the third one not being attached. We can connect together by changing the name of one of the nodes and fix this problem. Now save and close the model. So let us go back and try and open this same model in the older version, 9.6 version. We get an error message E511-1, also a warning N511-58. Whilst it looks like the model has opened, you are prevented from doing anything with it. Back in version 11, the correct way to go back to an earlier version is to save as version 9.6. So open the model, save as, select version 9.6, and say OK. This goes through a process of removing all the unsupported items that version 9.6 does not support. You will see that the non-linear hydra tests reverting back to linear, so inevitably the results will change. Back in version 9.6, this new model opens perfectly. Model comparison. Another common occurrence is when results of the analysis change when the user thinks the models are identical, or in this case, when they update the code year. This could be a result of many things, and it is hard to identify what is responsible for the change. It could be a fix to an error, or a change to the code equations, stress intensifications, or material properties, or any one or more of these things. So how can I identify what it is that causes the difference? First, I will make a copy of the model. Now I will open the original on the left and the copy on the right. This is one of the benefits of Autopipe in that you can have 2 sessions running side by side. Check the general model options. I will alter the code year for the copy model. Accepting the warnings about the changes. Now let's analyze both. And let us check the code stresses on the 2010 model version. It shows that we have a thermal ratio of 0.98 at the T, whilst on the 2014 side it shows a 5% overstress at the same location. So why? I will now create the output report for both model versions. I don't want to include all the reports, but I do want to include the input listing, which gives me an echo of the input. If I now locate these reports, I can now compare them. We can see that the time and the model name are different on each page, as you would expect. More importantly, I can see that the expansion rate is different, and this is due to an update in the material property library. It is larger on the 2014 version. No other changes show up in the input listing or the model options or combinations. There is one more difference in the code compliancy due to the addition of B31.J, which is set to be inactive. In the code compliancy report, we also see the expansion moment has increased slightly as a result of the change in the expansion rate, but the code stress, however, is a lot higher, and we now have an actual load included in line with the requirements of the later design code. We can see in detail the change in the program help. The addition of the axial stress in the thermal expansion condition was added in 2012, so therefore affects the 2014 analysis. The equation looks different in the 2010 version. So for identical models run at different code years in the same version, there can be a difference in the results, and this is a way of determining why. Thank you for attending. I hope you now have a better understanding of how the B communities, the program help, and the Readme file can help you not only understand the errors and warning messages you are getting, but also how to resolve the issue in the analysis. I encourage you to register and utilize the B communities for our products and the Bentley.com website for more information.